So, okay, now guys, so now we're going to move on next to a new topic, and we're going to be looking at matrices. Now, matrices and transformational geometry and vectors are closely associated. So hence, that's the reason why we kind of have this topic here. All right, now we want to first start off with our definition for a matrix. Now, note that plural, we have matrices, and singular, we have matrix. All right, now what is a matrix? Now, a matrix is what we define as a rectangular array of numbers. And what do we mean? We mean that the numbers are arranged so that they form something looking like a rectangle, right? And so that's what we refer to as a rectangular array. All right, now the rectangular array of numbers are arranged in rows and columns. And this is what we call a matrix. So the numbers are called entries or elements, and they are enclosed in a curved brackets, as you can see here. Now, we talk about the order of a matrix. Now, the order of a matrix simply defines how many rows and how many columns a matrix has. So when we say what is the order of a matrix, what we want you to do is to count the number of rows and count the number of columns. Now, if a matrix has 3 rows and 2 columns, then we say that the order of that matrix would be a 3x2 matrix, right? So a matrix with 3 rows and 2 columns would have an order of 3x2. So note, when we are defining the order of a matrix, the number of rows must come first, then the number of columns. So we have to arrange them in that order. So we are dealing with row by columns. How many rows by how many columns? Now, when you look at this matrix here that we have in this example, we can count the number of rows and we can count the number of columns. Now, what is the difference between rows and columns, students? Who can tell me, give me a clear distinction of what is a row and what is a column?
So rows run across and columns go down.
All right. So in this case, if we run a line across with the numbers, then this will give us our first row. This would give us our second row. So in this case, we would only have 2 rows. Now, if we should run some line going downwards, now we will have 1 column, 2 columns, 3 columns, 4 columns, 5 columns. So the order of this matrix is simply 2 by 5, meaning that it has 2 rows and 5 columns. All right. That should be pretty straightforward to everyone. Any question about that? Is it clear what the order of a matrix is? Now, sometimes you may refer to the order as dimension. So if we talk about the dimension of a matrix, we're really talking about the order of the matrix. So the order and dimension is really the same. All right, so moving along. Types of matrices. Now we have several types of matrices, and the ones that we'll be concerned with are as follows. So we have one, the row matrix. It is called a row matrix because it only has a single row. And so we can identify a row matrix by just looking at a matrix where the numbers going right across a single row. So here, if we are to draw a line, we see that we only have a single row going across. Now we talk about a column matrix that only has a single column, right? So once a matrix only has a single column, it's called a column matrix. Has a single row, it's called a row matrix. Now we talk about a null matrix. Now a null matrix is a matrix where the elements are all zero. So once you look at the values in the matrix, or the elements are the numbers in the matrix, and they're all zeros, then you know you have a null matrix. Now we talk about a square matrix. Now a square matrix has the same number of rows as columns. So in this case, we have one row, two rows. So we have two rows, and then we have two columns. All right, so once you have the same number of rows as columns, we say that we have a square matrix. Now, a square matrix also have what we call a leading diagonal. Now, the leading diagonal, if you know your geometry, a diagonal goes from one corner of the square to the next corner of the square. So for the leading diagonal, it has to do with the numbers starting from the upper left going down to the lower right. So these are the diagonal elements of the square matrix. And we also refer to these elements as the leading diagonal. The elements along here form the leading diagonal. All right, so moving on. Next we have what we call a diagonal matrix. Now a diagonal matrix has non-zero elements along the diagonal, right? So when the matrix has all the elements as zero, except for the diagonal, the matrix is referred to as a diagonal matrix. Now the other elements apart from the diagonal, they are zero. And because these elements are zeros, and only the diagonal elements are non-zeros, then this matrix is called a diagonal matrix. All right, so as we know, the diagonal runs from upper left to lower right. Now, next we talk about unit matrix. Now, a unit matrix, sometimes called identity matrix, is a diagonal matrix where the diagonal elements are one. So let me say that again. A unit matrix, sometimes called identity matrix, is a diagonal matrix where, so remember from up here, a diagonal matrix only have non-zero elements in the diagonal. When you look at the unit matrix, you have non-zero elements along the diagonal, but these non-zero elements are one. So the unit matrix, how you know your unit matrix, is that it is a diagonal matrix where the diagonal elements are all 1. So this is a unit matrix. All right, so if you are asked to write the unit matrix, this is the matrix that you would write. Now, if you can recall, when we were looking at some properties of commutative and distributive and associative property, we also looked at identities. And we talk about the additive identities and the multiplicative identity. Anybody remember what those are? Anybody remember what an identity is? Identity. Anybody remember what an identity is? We say 0 is called the additive identity. And why we call 0 the additive identity? If you add 0 to a number, you get back the same number. We call 1 the multiplicative identity, because when you multiply 1 by a number, you get back the same number. So an identity is an element. In this case, it's a matrix. When you use this matrix to multiply any other matrix, you will get back the matrix that you multiplied by. So for that reason, this is called a unit matrix or the identity matrix. So the identity matrix does not change the value of a matrix when you multiply by it. You just get back the same matrix. All right, so just to give you a quick recap, so we have pretty much 6 types of matrices: row matrix, column matrix, null matrix, square matrix, diagonal matrix, and last but not least, the unit matrix. Now, there are other types of matrix, but you won't be dealing with those at this level, right? So if you should pursue maths to a more advanced stage, you will come across other type of matrices. All right. Now, here we have the same general operation that we carry out on numbers. We carry out these operations on matrices. All right, so just as we are adding numbers, we should be able to add matrices. And we also should be able to subtract matrices. And we also should be able to multiply matrices. Now, dividing by a matrix is a complex thing. And so when we reach that point, we will see how we approach when we are divided by a matrix, what we really do. All right, so we're going to be now looking at addition and subtraction of matrices. Now, adding and subtracting matrices are pretty straightforward. So there are 2 things here that we need to note. So when we're adding or subtracting matrices, only matrices of the same order can be added or subtracted. Anybody know what that means? Only matrices of the same order can be added or subtracted. Now, can anybody remind me of what the order of a matrix is?
Row by column.
Right, so it is denoting how many rows by how many columns. Now, if we are going to add 2 matrices, the first thing that we need to ensure is that the 2 matrices that we're adding have the same order. If they don't have the same order, we cannot add them or we cannot subtract them. All right, so only matrices of the same order can be added or subtracted. All right, so that's the first thing to note. The second thing to note, when we're adding or subtracting matrices, we simply add their matching elements or their corresponding elements. So in other words, for these two sets of, for these two matrices here, the matching elements would be the A would match with the E, the B would match with the F, the C would match with the H, the D would match with this, sorry, the C would match with the G, and the D would match with the H. In other words, we can say A corresponds to E, B corresponds to F, C corresponds to G, and D corresponds to H. And we can clearly see why we say that these are corresponding elements, because they occupy the same position in both matrices. So when we are adding, we are only adding the corresponding elements. So when we're adding here now, we're adding A plus E to give you about the first element in the results. So we're adding corresponding elements. Then we're adding B plus F to get this, the next corresponding result. Then we're adding C plus G to get the corresponding elements here. Then we're adding B plus H to get this corresponding elements here. Right, so that's the way we add matrices, right? So adding matrices is pretty straightforward. The only thing that you have to be careful about when you're adding or subtracting matrices is when you're working with signs. All right, so here we have two examples. So if we're adding this matrix here, and one of the things you should note is that we oftentimes will use capital letters to label our matrix. So let's say that this is the matrix A, and this is the matrix B, and we're adding the matrix A and B. We're simply just going to add their corresponding elements. So we add 3 with 4, 5 with 7, 6 with 8, and 2 with 1. All right, so once you have done that, then we would simplify our result. 3 plus 4 gives you 7. 6 plus 8 gives you 14. 5 plus 7 gives you 12. And 2 plus 1 gives you 3. All right, so here, this third example, we're looking at subtracting matrices. So here, what we are doing now is subtracting one matrix from the other. So in the same light, if this was the matrix A, and this was the matrix B, then what we'll be doing, we'll be subtracting the matrix B from the matrix A. And so we are subtracting from corresponding elements. So we are subtracting the elements of B from the corresponding elements in A. So here we would have 6 minus 4, and then we would have 2 minus 3, then 1 minus 7, and 8 minus 5. All right, now once we have set them out like this, now we can simplify, because we know that 6 minus 4 will give you 2. So we'll get 2 for that. 2 minus 3 will give you minus 1. 1 minus 7 will give you, this value here should be a negative. So apparently the negative sign is missing here. So make that correction. So that should be minus 6. And then now 8 minus 5 will give you 3. 1 minus 3 give you -1. 6 minus 4 give you 2. All right, guys. So that's how we add and subtract matrices. All right. So here now we have another example. So now we're given these matrices. A equal to the matrix 3, 4, 2, 1. B equal to the matrix 2, 4, 3, 2. And so when we are adding them, we add their corresponding elements. So we have 3 plus 2 give you 5, 4 plus 3 give you 7, 2 plus 4 give you 6, and 1 plus 2 give you 3. So pretty straightforward. Now what we're going to be looking at next is matrix multiplication, or multiplication of matrices. Now for matrix multiplication, we have two types. We have scalar multiplication, and we have the general matrix multiplication. Now for scalar multiplication, a matrix may be multiplied by a number, and this number is referred to as a scalar. All right, to multiply a matrix by a number, we multiply each element in the matrix by that number. All right, so it is simple. It's like we are multiplying in a distributive sense. So whatever we have outside the matrix, so we have the number 3 outside the matrix. This is the scalar. And so when we are multiplying, we multiply each of these elements in the matrix by 3. So we'll have 3 times minus 5, 3 times 2, 3 times 0, 3 times x. So this is what we'll get. So simplifying this, 3 times -5 gives you -15, 3 times 0 gives you 0, 3 times 2 gives you 6, and 3 times x gives you 3x. All right. So from that now, this is another example. So we would have 3 times 2 give you 6, 3 times 1 give you 3, 3 times 6 give you 18, and 3 times 4 give you 12. So everybody is following so far. Any question? Any question? Raise your hand, guys. Raise your hand if you're following and you're understanding so far. All right, good. Now, the second type of matrix multiplication is what we refer to as general matrix multiplication. Now, in this case, you are multiplying one matrix by another matrix. Now, in order to multiply one matrix by another matrix, or to do general matrix multiplication, there are certain things that we have to take into consideration. So the conditions under which we can multiply two matrices, two or more matrices. First, two matrices can only be multiplied together if, and whenever you see the word if, what that means, if that condition exists, you can do the multiplication. But if that condition does not exist, then you can't do the multiplication. So when can you multiply two matrices? You can multiply two matrices if the number of columns in the first matrix, let me say that again, the number of columns in the first matrix is equal to the number of rows in the second matrix. Now, so if we're going to multiply two matrices, we need to check the order of the matrices. So now what we are saying, suppose the first matrix have an order of R1 row times C1 column. Now the value of R give you the number of rows. The value of C give you the number of columns. So that's the order. But so matrix 1 have row 1 times row 2 order. The second matrix have row 2 times column 2 order. Now, how do we know when these matrices can be multiplied? Now, once we write the order of the matrices, all we have to do is to look at the order and see whether or not the column of the first matrix. So this would be the column. So when you look at the order, this is the first matrix. So the number of in the order of the column of the first matrix. So the number of columns in the first matrix must equal to the number of rows in the second matrix. So you have to look at these two values and ensure that the two of them are the same before you can multiply the matrices. All right, so what does that mean? So suppose I have one matrix where the order is 2 times 4. So that's the order of one matrix. And we have another matrix where the order is 3 times 4. Can these two matrices multiply together? Can they be multiplied? Ms. Wesam?
No, sir.
All right, why you say that they can multiply?
Sir, this I have 2 rows.
So if this is the first matrix,
Mm.
and we are looking at row by column. So we have 2 rows, 4 columns. That's the order of the first matrix. The second matrix, we have 3 rows, 4 columns. But based on the condition that we have up here, the columns in the first, the number of columns in the first must be equal to the number of rows in the second. So if these two values are not the same, you can't multiply. So 4 does not equal to 3. So because the 4 and the 3 not equal, we can't multiply these matrices. Is that clear? Guys?
Yes, sir.
All right. If C1 does not equal to R2, then the two matrices cannot be multiplied. So if we have one matrix of a 2 by 4 and the other one which is a 4 by 8, if you look at the order for the first matrix, the column is 4, and for the second matrix, the row is also 4. So it means that these two matrices can be multiplied because the column in the first matrix is the same as the row in the second matrix. So at all times before you jump and start multiply, you have to check this to ensure that this condition is met. Because if the condition is not met, you will be doing foolishness, so to speak. All right, so we see that C1 is equal to 4 and R2 is also equal to 4. So therefore the two matrices can be multiplied. All right, rules when we're multiplying matrices now. Now when we are multiplying general matrix, when we're carrying out general matrix multiplication, we say that we use the rows of the first matrix multiplying with the columns of the second matrix. Now, oftentimes students may confuse the rules with the condition. Now, the condition states that you check the number of columns in the first matrix with the number of rows in the second matrix. That's the condition The rule says when you're multiplying, you multiply the rows of the first matrix with the column of the second matrix. Right? So when we are multiplying row by columns. But when we are checking the condition, we check the column in the first and the row in the second. Is that clear? Raise your hand.
Sir, repeat.
So we have two things that we learn about general multiplication here. We say that in order for two matrices to be able to multiply, we have to ensure that the number of columns in the first matrix equal the number of rows in the second matrix. If that condition is satisfied, then you can multiply the matrices. If that condition is not satisfied, the matrices cannot be multiplied. Now, the rule when we're multiplying matrices, after you check the condition, the rule when you multiply matrices is that we use the rows of the first matrix to multiply the columns of the second matrix. So for the multiplication rule, we are multiplying rows of first matrix times columns of second matrix. Is that clear?
Yes, sir.
So, all right, so this is what it would look like from a concept point of view, right? So the first matrix, we are using rows, and we are using the rows to multiply the columns. Now, what we notice here, if we have two rows, what we do first, we take the first row, multiply by the first column, take the first row again times the second column. So let me walk you through the procedure. So we use first row times first column, then we use first row again times second column. Right? Now, after we finish using the first row now, we go to the second row. So we now use second row times first column, then second row again times second column. Right? So if we follow that pattern, then what we see here, if we multiply the first row by the first column, then we would get this. If we multiply the first row again with the second column, we will get this. So the first row by the first column give you the first elements at the top. The first row by the second column give you the second elements at the top. Question, Ms. Wesam?
Yes, sir. So I'm confused right now, sir. Was it not that the same amount in the row should be the same amount in the column?
All right, so this is just a symbolic representation of what you'll be doing. So when we actually put in the numbers, you will see a little bit more clarity of what we're doing.
Okay, sir.
So what I'm giving you is the general idea that we're using the rows of the first matrix times the column of the second matrix. So this is the general output. So first row by first column, first row in the first matrix times first column will give you the top elements. First row again by second column will give you these top elements over here. Then we go second row with first column, give you these bottom element. Second row with second column, give you these second elements here. Now, the thing is about when we're doing matrix multiplication, the row by column process can be done in two different ways. And so what you need to do is to stick to one way that you're comfortable with, right? So once you are doing it, you will get an idea. All right, so here's an example. Now, this is how it works. So we are multiplying first row with first column. Now, how do we multiply? We multiply first element with first element, second element with second element. So in other words, we use the 2 times the 5, then we use the 3 times the 3. So 2 first element with first element, second element with second element, right? But this is what we do. So we multiply 2 times 5, then we are going to add that to 3 times 3. All right, so that's the general procedure. So let us follow what I'm saying now. So if I'm going to multiply this first row by this first column, I'm going to take the first element of this row times the first element of this column. So that would be 2 times 5. Then I take the second element of the same row with the second element of the first column. So now this would be 3 times 3. So we are going to add 3 times 3 to what we did before. Any questions so far? All right, so let me do one more. So now, if we are going to now multiply the first row by the second column, we're doing it in the same way. So we're going to take the first element, 2 times 2. So we get this, 2 times 2. Then we are going to add, then we take 3 times 6. So we get